In 2014, our little WAM Engineering was the first company that we're aware of that brought to the public's attention this thing called Zenith Error. I've done a few videos on Zenith Error and I invite you to watch them. Since that time, and particularly since 2020, Zenith Error has been a subject of heavy and concerted study on our side. I've involved three different engineers, three different types of computational analysis, and multiple empirical studies. These studies will culminate in a paper we expect to submit to the Journal of Audio Engineering Society this year, 2025. But the public has picked up on this term, Zenith Error, and are starting to misuse it. And I feel the need to get behind it because people are starting to confuse Zenith Error for offset angle, that is the cantilever. Now, Zenith Error is the degree to which, if you look at the, say, the left channel contact point of the stylus and the right channel contact point of the stylus, and you draw a line between them, it's the degree to which that line is not perpendicular to the cantilever. Industry tolerance is actually plus minus 5 degrees on most stylus cantilever assemblies, which is crazy, but in any case. So Zenith Error can't be fixed without removing the stylus and remounting it. Not something I recommend. You can correct for Zenith Error by using the Wally Zenith and purposefully misaligning the cantilever in the opposite direction of the Zenith Error to the same degree. So for example, if you had a Zenith Error of minus 3 degrees, then you would purposefully misalign the cantilever by 3 degrees in the opposite direction in order to assure that when the stylus courses through the groove, that the left channel and right channel read the groove simultaneously in time. Now, the public has picked up on this term, adjusting zenith. Well, there is no adjusting zenith, and I think what they're referring to is rotating the cartridge to align the cantilever. But unless you know what your zenith error is, you aren't doing anything with your zenith error. You're just aligning the cantilever. These are two very different things. Two different things that result in different types of distortion. When zenith error exists, that is a linear distortion, a problem of phase. There's a phase and time problem between left and right channels. Aligning your cantilever to be tangential at the null points, well, when it's not tangential to null points, that creates a nonlinear distortion that is well documented and has been known about since the 1930s that throws off predominantly second order harmonic distortion. So by correcting for zenith error, by purposefully misaligning the cantilever, you are creating a new type of distortion in this angular error, a horizontal tracking angle error, that creates a nonlinear distortion, mostly in form of second order harmonic distortion. But this cantilever angular error is far more benign to our ears than is zenith error. We will write about the audibility of these two types of distortion a bit in our paper that we will submit to the AES. Just suffice it to say that if you don't know what your cartridge's zenith error is, then when you're aligning that cantilever, you aren't adjusting zenith. There's no such thing as adjusting zenith. You can only correct for zenith error, but if you don't know what it is, you're not doing anything with it. You're just aligning the cantilever like we've been doing for decades. I think it's important for us to stop saying things like, I'm adjusting zenith, because it's going to keep us from understanding two very important variables that we would need to consider in order to chase playback optimization. We're confusing them. We're conflating them. While they're certainly related to each other, it's not the same thing. So let's try to keep them separate, and we can correct for zenith error, or we can align our offset angle of our cantilever to be tangential at the null point. Keep those distinctions separate so we can track, know, and understand the variables that go into the performance that we ultimately hear from our speakers. Until next week, there it is, another soundbite video. See ya.